All right, example 7.3. Use fzero to determine the first non-trivial root of sine x is equal to x squared, where x is in radians. By non-trivial, I mean x is greater than 0. Okay, excellent. So let's go over to MATLAB, set this baby up, and solve it. Okay, here I am in MATLAB, and I've tried to size things up, so I have my problem statement down here, so I can remember what that equation is we're trying to solve. And I have some room over here, because I know I'll use fplot to estimate the root locations, and so I'll have space so I can plot that, put the plot over here while still working in my MATLAB command window. Okay. All right, so we want to find the roots of this equation. Okay, so when it comes to solving for roots, I know I'm going to create a function, an error function. Okay, so let's do it. So it'll be function res is equal to, what do we want to call it? Maybe sin error, and it'll have an input of x. Okay, so our error function is going to have a single output and a single input. I call the input capital X because I'll try and vectorize my function so it'll work for scalars and vectors. Okay. So the first thing we'll have to do, or what we'll actually have to calculate in this error function, is we want to take this expression and we want to rewrite it so that my function evaluates to 0 when I found a solution to my equation. Okay. So I want to find values of x that satisfy this expression. Okay, so finding x values that satisfy this expression is the same as finding values of x such that sine x minus x squared is equal to 0. And that's how I want to set my error function up. I want to set it up so that it evaluates to 0 when I found a solution. This way, I can set my problem up to use a bracketing strategy. Right? So if I'm looking for my function is equal to 0, I know that it's, to the left and right of that, the sign of my function is going to be different. Right? My function has to change signs if it's going to cross 0 over some range. So my error function will take the range or form of sine x minus x squared, where I was using a capital X as my input. Okay. And I just add the period before my exponentiation to vectorize it. Okay, I have my documentation, so I'll put my little function signature up here. Okay, and then comments. This is error function to solve for zeros of sine x is equal to x squared. Okay, cool. So if I save it, MATLAB will suggest sine error or sin error, which agrees with my function signature here. Okay. Okay. So next we want to get an estimate of our the location of our zeros. Okay. So we'll use fplot, and so now when you use fplot, we'll need to specify the range to plot over. So if I look at my function here, okay, I know that sine x, so sine is going to be bound between 0 and 1. Okay. So therefore, our values of x, right? So sine x is equal to x squared, should also be bound between 0 and 1, right? Since sine of x is bound between 0 and 1, then x squared is going to be bound between 0 and 1, so x is going to be bound between 0 and 1. Okay, so when we plot, so fplot, give it my function signature, sin error. Okay, let's plot over the range 0 to 1. Okay, cool. Shrink it just a little bit, and then to help me visualize, I'm going to turn grid on. Okay, so here's my trivial root, so it's 0. So we're not looking for that one. We're looking at our first non-trivial root, which will happen over here, which is between 0.8 and 1. So to find my 0, okay, maybe I'll call it solution, SOL, would be equal to fzero at sin error, give it my function handle. Okay, and in terms of search range, we just need to give something greater than 0, but the smaller the range, the better. So let's just search over 0.8 to 1. In doing so, I get a solution of 0.8767, okay, which looks very reasonable. Okay, great. Okay, so if you want, you can turn me off, but since this problem looks fairly simple, let's try and show how we can use an anonymous function to obtain the same result. Okay, so I'm going to close this plot, okay, and I'm going to clear everything. So I'm going to clear my variables, clear my workspace, and let me close this so it's like we're starting from scratch. Okay. So this is a fairly simple expression. So this is something I ought to be able to create an error function pretty readily in the command window. Okay, so how I create an error function is, okay, I'm going to assign function handle to a variable. So maybe I still call this sin error, and let me give it an A for an anonymous, since I have that sin error function here. It'll be type function handle with a single input of x, and what'll be, you know, what was in the body of that function is our error function, which is sine x minus x squared. Okay, so in terms of setting up this anonymous function, right? So if I first look at the right-hand side, because this is a variable assignment, okay, I'm saying this is of type function handle. Okay, so by function handle, so that just gives us a way to refer to the function without necessarily passing variables. Okay, so it's of type function handle. This function will have a single input variable, x, and then what was in the body of that function, or what I want this expression to be, what I want the function to do, is evaluate sine x minus x squared. Okay, so I can use fplot just like before. Okay, only here, okay, sin error A is already of type function handle, so I don't need the @ sign. Okay, but I can create my plot, and it looks identical to what we had before. Oops. And I can turn my grid on. Okay, and then, you know, if I want to look for my solution, I can use fzero just like before. Again, first argument before is our function handle. Sin error A is already of type function handle, so I don't need the @ symbol. And let's again search over the range 0.8 to 1. Okay, cool. We get exactly the same result as before. All of this could be done entirely in your command window, or you might save it to a script for the purpose of saving it. Okay, cool.